Welcome to this lesson on the complete control system for engines. In particular, this is called FADEC, which stands for Full Authority Digital Engine Control. And it's actually a system. We're going to go through the different components involved and also look at the inputs from the aircraft systems that go into the ECU. Okay, and again, there's really not too much to it. You just need to know locations of maybe some of the sensors, etc. All right, let's go ahead and get started on this. And of course, you're going to have a test on this. We'll kind of go back and forth so that you can be familiar with some of the test questions that you'll be asked. All right, so let's go ahead and get an idea first what what is FADEC. Okay, FADEC again stands for Full Authority Digital Engine Control, and this is essentially a system utilizing the ECU, which is your engine control unit, and essentially this is controlling power to the engines. Okay, it's regulating all of that. It uses the power supply of a PMA, so you have a permanent magnet alternator that is the supply source or the power source for the whole FADEC system. Okay, and that's when the engine is running. When the engine is not running, it just runs off the electrical power from the aircraft. Okay. All right, so when we talk about complete control, that's pretty heavy-duty stuff, right? And it does. I mean, the main thing, of course, with the engines is being able to regulate the thrust, and therefore, with the FADEC, it's going to be constantly monitoring and giving indication in the cockpit to what's happening with different parameters. Now, when we talk about FADEC, we can break this up as far as it's controlling and monitoring different things into primary and secondary parameters. So let's just look at some primary parameters. I mean, think for a moment, what would be a primary parameter? Okay, well, thrust, right? How much thrust at X point in time. It's constantly changing, right? The demand requirement, depending on the conditions and circumstances at that moment up in flight. So it's constantly getting data from the aircraft systems to then, give the commands, get the output going to from the aircraft systems to the ECU, and again being able to do a feedback and just creating that regulation to different aircraft systems that have to do with the engine, of course. So with here, your primary parameters are going to be your N1 and your N2 speeds, as well as your exhaust gas temperature, so your EGT. Essentially, it's making sure that it's not exceeding limits. There's indication that will be given, obviously, with EGT going outside of those limits. And as far as the N1 and N2 speeds, it does regulate that to make sure it's within the limits that it needs to be. So those are your primary parameters. Another parameter I would consider on a primary side versus secondary is your fuel control. So it's also in charge of that as well as fuel control. Also thrust reverse operations and your active turbine clearance, your clearance control. It's also responsible for that. Now, some of your secondary parameters will be like your oil temperature. Okay, so that's an example of a secondary parameter. And I'm just going to give you an idea of the different aspects or parameters that the FADEC is affecting. What is it doing? How is it controlling? And it's controlling these different things that I just mentioned. And how is it doing that? With anything, like we talk about systems, we have inputs and outputs. It has to be getting some information from somewhere in order to make those, in order to then have a command of, a regulation of fuel control or, and also, by the way, also it controls the fuel control valve. This is the return fuel to the fuel tanks. But here, so it has to have input. And your aircraft systems, from your air data computers, when we talk about pressure and temperature. Okay, we talk about those sensors, which we're going to be getting into a little bit more detail, but we do have sensors here. They're going to be temperature and your pressure sensors. Those are coming from your air data computers, and then going into a component that we'll get into in just a little bit. But that gives you an idea about what it's affecting. That's what I wanted you to understand. Okay. Let me talk a little bit about the power supply. I just want to go a little bit into it. Nothing really that critical, but just kind of an introduction to the permanent magnet alternator. And okay, keep in mind, if it's on the ground, if you have the engine shut down, then the PMA is not going to be supplying power to that FADEC. Okay, it's going to be the electrical power from the aircraft. If it's in flight, and obviously the engine's running, but we're just assuming it's going to be in flight, then it's going to be drawing its power from the PMAs. And there are 2 FADECs, by the way. Okay, just so we're clear, there's a FADEC for each engine. Each engine has its own FADEC, and also, just for kind of a fail-safe setup, is there are 2 channels. So there's dual channels for each of those FADECs for each of the engines, right? Okay, 1 FADEC per engine. And so you have dual inputs and dual outputs. As a result, they are named as channels A and B. Now, there are some parameters that don't need that dual input and output, and that would be for your monitoring and indicating. Those are just going on a single channel. Now remember, when you have duals, you'll know, you've been around aircraft enough to know that this is just in case one fails. So we have those channels A and B, and channel A as well as B each have their kind of what they're in charge of. And if for some reason one of them goes down or it fails, then the other can take over. Now, there are instances where that's not possible, just by the sheer nature of what it's what it's giving output to, as far as the type of system. And when that happens, then there's a fail-safe in there, so that the system that needs to get that command is not getting it, but there's a fail-safe position that it'll get into if that occurs. So kind of giving you an idea that we've got redundant systems here with having 2 channels for each FADEC, channels A and B as they are named, and each of those channels are responsible for certain systems, and if one fails, the other one takes over if it can. If it cannot, by the sheer nature of what it's trying to supply, then it's gonna that system itself is actually gonna have a fail-safe position to be in. Okay, now your permanent magnet alternator is the power supply. Also, besides the PMA, there is a FADEC, kind of a backup alternator. So there's another one in there, just as an extra power source. But what we're talking about right now is a permanent magnetic alternator, your PMA. And I'm going to go into details on it. Obviously, it has to be designed and engineered to support 2 channels. So obviously, you got 2 windings, obviously one for each channel, for it to support, from a power standpoint. Okay. And again, these things are lubricated. They are lubricated with the engine oil that actually goes through or sits in the accessory gearbox. So it is considered a lubricated alternator. And as far as the range or power signal, it ranges up to 311 volts AC, and obviously depends on how fast the core is going. Okay, but I just wanted to mention the permanent magnet alternator to you a little bit. Okay, all right, now let's go ahead and remember I said that we have aircraft systems inputs that go to this component that I said we're going to get into. And by the way, the component I'm referring to, so it's not a mystery anymore, is your ECU. Okay, your ECU, you might have heard me say that in some other lessons if you've been through those already. But ECU is your electronic control unit. Okay, It's your electronic control unit, and it's kind of like your go-between. Then you have also your EIU, which is your engine interface unit, and that's kind of a little bit of a translator for the ECU. Typically your EIU is interfaced with your secondary parameters, not so much with your primaries. Usually there's just a direct connection between the input from the aircraft systems that go directly to the ECU. And just so you can kind of a structure of the ECU just a little bit. It has ports, obviously, so you can have the connections, the signals going into it so that it can then have an output. All right, let's go ahead and go into some of the sensors, and keep in mind, and I'll just mention it now, on some aircraft there may be optional sensors. So if I happen to mention it now and say, well, this may or may not be, and just be aware you may not find it in the aircraft that you are working on. And I'll explain a little bit, and I'll explain this a little bit more. But here's what we have on the temperature side, because remember I said there's temperature and pressure sensors. Number one, let's just kind of talk about our temperature sensors. It's not a whole lot, but your temperature sensors are going to be, what's important to make sure temperature doesn't go too high. Okay, we got the air inlet, right? Air inlet, and then also your high pressure compressor area. So with here you have your T25, and this one here is measuring air temperature downstream of the booster. Okay, so it's called the booster discharge temperature sensor, and this one is located roughly at the 545 upstream of the variable bleed valve in the fan frame. Okay, that's T25. Your T12. Okay, so there's T25 and T12. You have at the 1 o'clock position, and that's located on the air inlet cowl. Okay, and that's measuring the engine air intake, air temperature. Okay, and then you also have a T3. Your T3 is your compressor discharge, and that's on the combustion case itself at the 12 o'clock position. So you have, I just named 3 different temperature sensors that to be aware of, and you can recognize they're kind of where they're located, like I just said a bit ago. Okay. And these temperature sensors, I mean, it's not important to go into the detail of the design of it. Just, as far as installation or removal, just make sure you follow, obviously, the aircraft maintenance manuals related to that. All right. Now, remember I said that there may be a temperature sensor that doesn't exist on some aircraft. I'm talking about Airbus, but then maybe sometime you'll come across, a sensor that you didn't see it in the other ones, and that would be your T5 sensor. And the reason why is because it's an optional package that is purchased by the buyer. So they can decide to have this optional package that includes these extra sensors. And that's what that is. It's a temperature sensor. If it's there, this T5 one, then it's going to be located on the turbine rear frame. Okay, it's just for extra monitoring. Again, you may not even see it there because it doesn't exist. Okay, now what about pressure sensors? Let's talk a little bit about some pressure sensors that you might have, and then I'll get into the ECU here. All right, with the pressure sensors, you have PO, or your P0 actually, is ambient pressure, and then your PS12 is your static pressure in the inlet cowl, and then you also have your PS3 static pressure, which is the at the outlet of the high pressure compressor. And then along with that, again, if it's a customer who requested an extra, wanted extra sensors for monitoring, then this one's going to contain 2 other pressure sensors. It's not important to know the numbers, just know that you could have extra pressure sensors just as well as the temperature sensors. Okay, if that optional package has been installed. Okay. All right, so I just wanted to give you the familiarity with the temperature and pressure sensors. Okay, so you have some of that knowledge. Then I'm going to come back to a little bit on the pressure subsystem, because that's actually part of the ECU, but I definitely want to go ahead and get into the ECU at this point. All right, and actually before we do that, let's go ahead and, I don't want to be remiss in not mentioning some test questions or potential test questions to you. So let's just go ahead and continue with this by using some test questions. How many independent channels does the full authority digital engine control system, which is FADEC, how many does it have? Okay, your choices are 3 or 2. Okay, remember I said there were 2, channels A and B. Okay, the channels can only operate with the cross-channel data link. I know I did not mention the cross-channel data link yet, but that actually has to do with what I said earlier, but it's a true-false statement. The channels can only operate with the cross-channel data link. Is that true or false? That is false. It can. The whole idea is a cross-channel data link enables the signals to be crossed over to the other channel. If there's some failure in one, there's just an opportunity for basically dual function. Okay, from which component does the ECU receive commands? From which component? Okay, is it going to be the HMU or is it, actually I meant the EIU, excuse me. So from which component does the EIU receive commands? Is it the ECU or the HMU? Okay, it's actually the ECU. And actually, if you see the diagram from the beginning of this video, I put in parentheses the EIU because the EIU is only used for, well, it's not typically used for primary parameters, but it will be used for secondary parameters, and that's why. All right, flight control unit. The flight control unit sends inputs to the ECU. Is that true or false? And you'll see it written as FCU. That's flight control unit. Okay, it's true. It does send inputs to the ECU. Remember flight control unit? This is aircraft data systems, right? And those signals are going to be sent to the ECU. Okay. All right. Let me just give you some more, because I don't want to forget to expose you to these questions. Most communications between the ECU and the aircraft systems are transmitted how? Is it via hardwiring or via digital data buses? The clue is FADEC, okay, and the letter D stands for digital, right? Full authority digital engine control. Okay, so the answer is via digital data buses. So instead of, it's not so much through hardwiring as it is through digital, so that's what it stands for. All right, what happens when one of the channels fails to operate a component and the other channel is unable to do so by architecture, not by failure? Okay, 2 choices. Number 1, the component is commanded to a fail-safe position, or a warning is indicated visually and orally in the cockpit. Okay, it's the first answer. Remember what I said? The component itself is just going to be put in a fail-safe position. That's the key thing. Okay, and just remember what's one of the functions of the FADEC? Is it to control the flight controls or to control the fuel flow and clearance control systems? Okay, it's the last one, and I said that earlier. Okay, let's go ahead and go into the ECU. This is the electronic control unit. This is the heart of it all. And what you'll find it actually mounted to this is going to be a chassis. There's going to be a shear plate there, and those are those ports for your sensors. Okay, just kind of a side note. Your electronic control unit, remember what I said, it's a dual channel. control, and it's essentially a little computer. Well, I wouldn't say little, it's not exactly little as far as its dimension, but it is essentially a computer, enabling, just having that ability to receive signals and also to give them out. You have 4 mounting bolts. These bolts are designed to handle a shock, so it's important to mount those properly and make sure you have the proper bolts, that you're not just grabbing bolts that look alike, because they are rated for isolation, noise isolation. Okay, so we have the ECU. It's going to be receiving inlet condition data from the aircraft data computers, your ADCs. Remember what I said, that's what happens. And it's going to be getting data from the different sensors I just mentioned. Remember, like temperature sensors, your T25, T12, and then you have pressure sensors as well. Okay, it's not important to remember what numbers, just know that you have pressure and temperature sensors located either at the combustion on the combustion case or on the fan frame, because that's what's important, right? Is the temperature at the air inlet, okay, the engine air intake area. All right, your ECU also performs your ignition, your starter, aspects. So it actually sends signals to the starter air valve solenoid, and that's also the thrust reverser. That's also what it's affecting. And you also have hardware and software with this ECU for doing what it's doing. Okay. The other thing too, remember I mentioned about the fuel control valve, because the fuel control is also, the fuel is also used for IDG cooling, so it's also participating in that as far as giving commands and maintaining, just maintaining the temperatures with that. Okay. All right, so that's your ECU, and power sources for ECU. Remember, I said is powered by the magnetic alternator. Okay. And you have those there. As far as your power sources, those are routed through the EIU. Remember I said the engine interface unit. Okay, when you have kind of secondary parameters, you're going to have signals going to the EIU before it goes to ECU. Okay, and so their EIU is connected to the ECU. All right, so that gives you an idea there. And as far as what you're going to see on the ground power panel, because you have the ground power panel, we're going to get into the troubleshooting reports and kind of the reports that you'll see in the cockpit in just a little bit. I just wanted to give you a little orientation with the ECU. And by the way, the ECU is located on the right hand side of the fan inlet case at the 4 o'clock position. So, just so you know where it's located. Some of the things you're going to see on display are going to be your FADEC ground power, push button that's going to be there for on and off, so it can receive obviously power. Okay. Okay, and let's just kind of go over. Let's go ahead and go on to some of the things that you're going to see on display in the cockpit as it relates to the ECU. There's it actually has its own, like a lot of these computers do anyway. They have their own checking, so they're looking for faults in itself, and then giving indication of that. But here, let's just look at the troubleshooting report just to start. This one's going to just show certain parameters, not everything, because remember I mentioned oil temperature is one of the secondary parameters. It may or may not show that. Here, there's just going to be a handful of them because there's a list, and that's the troubleshooting report is going to show that. Okay, and when that fault first appears, it's going to show up on that report. There's 2 pages to the report, and it's going to be, as far as the different, if there are several faults, if there's more than one fault, it's going to show the most recent one at the top, and then work its way in that order. the way it does that. Okay. And of course you have fault message and a normal mode message. And of course if nothing's to be done, there'll be a message on there that says no faults recorded. Okay. Okay, and then doing the test, the FADEC test, this is the ECU FADEC test. You have two parts to this, and if you have the starter error available at the beginning, then a motoring test, can be done. Otherwise, you're not going to have a motoring test. Okay, and you have you want to have the mode selector on norm, and of course leave the engine master switches lever on. And once that's there, then you're going to see test active on the screen. Okay, that's your FADEC test. You will have also, besides the troubleshooting report, you'll also be able to see the scheduled maintenance report. And that way you can see kind of what happened, just like on these, last leg report, and see if there's any information there that would be helpful for you doing maintenance on your shift. So there's definitely the scheduled maintenance report on there. Okay. You also have terminated report. If the mode selection is on the ignition start, then the menu mode's going to stop the current function, and it's going to show on their terminated report screen. Okay, so it shuts off essentially if you have that ignition start on. Okay. All right, and then you have specific data. These are your power setting max values. In particular, we're talking about the N1 and N2. Remember I said the most important parameters are going to be related to thrust, which is going to be your N1 and N2, and then your exhaust gas temperature as well. Okay, so those all would be displayed on as far as specific data on the report. All right. Okay, so that gives you an idea with the reports on the screen. The ECU, we've gone over that. The power supply is what? Okay, so magnetic alternator. Unless the engine's not running, then the power source is just coming from the electrical supply from the aircraft. Okay, let's do some test questions. I don't want to forget to do that. All right, what is the function of the ECU? Okay, is it to be the bridge between communications between the aircraft systems and the FADEC, or to receive commands from the HMU? Okay, what's A? I mentioned about aircraft systems too, and the FADEC system. Of what is the FADEC system comprised? Because it is a system. Okay, is it for A, the flight control devices and the sensors, or the ECU and related components and sensors? Okay, so the last answer. What are considered primary parameters as it relates to the aircraft systems and the FADEC? Is it EGT and fuel temperature, or air conditioning and thrust? Okay, it's the first answer, right? EGT and fuel temperature. Fuel, I didn't mention, we talk about fuel control. Obviously, it's going to be monitoring fuel temperature as well, and ensuring, if you took the engine fuel and control, you'll understand what I'm saying now, that it's monitoring that fuel temperature. It has to cool it down when it's going back to tank. Okay, where are the engine interface units located? I know I mentioned a few locations. Okay, is it in the forward cargo compartment, or is it in a concentrator located in the right-hand avionics bay? Okay, I didn't mention this, so you're getting it now. Okay, where are the engine interface units? They're actually located in a concentrator that's located in the right-hand avionics bay. Okay, what is the main function of the EIU? That's your engine interface unit. Is it to transfer data from the cockpit to the ECUs on each engine, or is it to transfer data for secondary parameters? Okay, it's the latter. Remember I said about secondary parameters. It doesn't have a direct connection to the ECU the way the primary parameters do. Okay, which component is used to start the engines? Is it IEUs or ECUs? Okay, to start the engines, it's EIUs. All right, where is the ECU located on the engines? Is it left hand or right hand side of the fan inlet case? Okay, it's right hand side. Remember, right hand side, ECU, right hand. Okay, what is the function of the permanent magnet generator of the ECU? Is it to supply each channel with 3-phase AC power, or supplies one channel with single-phase AC and the other channel with 3-phase AC power? Okay, just so you know, it is option A. It's the first one. It's supplying 3-phase power, by the way. There's no single phase that's being supplied here. It's all 3-phase. All right. In order for power to be supplied to the ECU, what condition needs to exist? This has to do with N1 speed, or it could be N2 speed. Okay. I know I didn't mention the percentages, but I'm just throwing it out here. All right, N1 is below 60%, or N2 is below 58%. Okay, it's option B. N2 is below 58%. Okay, then there's power that will be supplied to the ECU. The PMA, okay, your permanent magnet alternator, has how many bearings? The answer is 0. I didn't mention about bearings, but it doesn't have any bearings. Where is the PMA located? Okay, I did mention, okay, is it left forward side or right hand side of the fan inlet case? Okay, left forward side. The PMA is actually located in the left forward side of the accessory gearbox. Okay, just remember left side. Remember I mentioned about also that it's a wet alternator, meaning it has lubrication, and it's a lubricated one, and lubrication's coming from the engine oil that's in the accessory gearbox. Okay, the PMA has a what and a what. I know I didn't go into describing this, but you know, we talk about fan blades, and especially if you got into power plant, we talk about rotary things and stator for stationary. Okay, so it has a what and a what, which encloses 2 sets of windings. I did say it had 2 windings, but they're not called primary controller and auxiliary controller. They are rotor and a stator. Okay, so there's a rotor and a stator, which is enclosed, which encloses 2 sets of windings. Okay. All right. Regarding the ECU design, the ECU channel A inputs are different from the ECU channel B inputs. Is that true or false? Okay, that's actually false. They're the same for both. They're the same for both. Okay. All right, let's go ahead and go back to a little more on our lesson. And I'm going to just go a little bit into, remember I said about aircraft systems, and there's 8 air data computers, and I just want to touch a little, mention a few other, specifically some of the systems or controllers that are involved. All right, so let's see, what do we have here? Okay, remember I said, but we also have fail-safes, with all these systems. But we have your aiders. Okay, your air data. Remember I said about air data computers, you have your initial inertial reference system. So you have signals that are coming from those and going to the ECU. Okay. All right, so that's what you have. You've got, channel B provides the same outputs as channel A to the AC computers, the aircraft computers. Okay. Remember I said about the cross-channel data link? It just enables both of them to have access, but if one of them truly, by design, cannot provide provide for the way the first channel did, let's say it's channel A, then that component is just going to go into a fail-safe position. All right. Okay. So you have also flight warning computers, your display management computers, your FMGCs, which are your flight management guidance computers, where they're receiving signals from the ECU. Channel A, as far as, remember I said what it's in charge of a little bit? Those are, Channel A is actually providing outputs to the flight data interface and management unit. The things I just mentioned just right now, which is your flight warning computers, your display management computers, etc. When you're talking about the Channel B outputs, they're providing the same outputs as Channel A, but they're going through a different network. Okay. All right. Okay, so let's just go back to some of the questions and see where we're at on this. Okay, regarding the ECU, I know I mentioned that too. Let's see, to what does ECU Channel A output? Okay, I'm using that as a verb, by the way. Where does it output to? Okay, does it output to the ADARUs and DMCs or the FDMIU and EIU? Okay, it's actually going to the FDMIU and EIU. To what does ECU Channel B output? Okay, it's going to the same thing, FDMIU and your EIU. All right, the ECU channels A and B outputs use separate bus networks. Is that true or false? Okay, that actually is true. All right, what is an unlimited time dispatch fault? I know I didn't mention that one, but you're getting it right now. What is an unlimited time dispatch fault? Okay, is it the fault can remain uncorrected forever and never be fixed? Okay, that's not likely. Or the fault can remain uncorrected within an unlimited time frame. Okay, that means option B. It means that the fault can remain uncorrected within an unlimited time frame. Doesn't mean you don't want to ever fix it. Okay, when does the no faults recorder message display? Okay, I didn't mention about number of flight legs, etc., but when does that actually show up? No faults recorder. Okay, is it when there are no faults detected within the last 24 flight legs, or when there are no faults detected within the last 64 flight legs? Okay, it's the latter. When there's no faults detected within the last 64 flight legs. All right. When will you see the message function terminated? Okay, is that when the mode selector is turned on ignition start, or when the engine master full lever is set to on? Okay, it's actually the first one. Okay, when the mode selector is in an ignition start. Okay, the ECU pressure subsystem. The pressure subsystem, by the way, is part of the ECU. It has several ports, actually it has 5, that obviously are receiving signals from the sensors. Okay, so the ECU's pressure subsystem consists of, okay, we have transducer assemblies, by the way, and converter units. They're not transponders, they're transducers. So we have transducer assemblies, and that's the correct answer, by the way. All right, probably I'm not going to ask this, but just so you have it, resistive thermal devices, I mean, it's pretty standard for the type of sensors that we're talking about. And so if you see a statement that resistive thermal devices are considered management type of sensors, that actually is a true statement. That is true. The pressure sensors are mostly located on the shear plate. Shear plate is actually attached, by the way, to the ECU. Okay, and that's a true statement. Where is the T12 sensor mounted on the air inlet cowl? Is it the 4 o'clock or the 1 o'clock position? I tell you, if you know this is great. It gives you just more orientation. Not that you have to memorize, but it is nice to just have some of the stuff in your head, and then of course you're always going to be reading the manual. Aircraft maintenance manual, as it states what you need to do and what it is and all that as far as identification. But T12 sensor is located at the 1 o'clock position on the inlet air inlet cowl. Okay. All right. Which temperature sensor is behind the fuel nozzles? I didn't mention the fuel nozzle part. I did mention the location of it because I said on the combustion case. And by the way, that was T3. T5 is an optional part of the optional package. So T3 is the answer. Okay, T3. Remember that, T3. Okay. Also, I didn't mention the identification plug. I probably missed a couple of questions, but missed them meaning I didn't mention them. I didn't ask you the questions. But let's just kind of, well, I do mention, do remember about the non-motoring and motoring test. Okay, remember what I said about the ECU FADEC test? What does a non-motoring test mean? Okay, it means it's running when the starter air is not available. So if starter air is not available, then you have a non-motoring test that's going on. And then of course if it is, then you are. Right? Okay, one last thing and then we will conclude this. I just want to touch on, just so you have a awareness of it, the identification plug. This is a connector plug, and what this is, the connector transmits the signals to the ECU. And what is it signaling? What information is it sending to the ECU? Well, it's giving actually the engine serial number. We know we talked about the ID plug. We're talking about the serial number, the engine family, thrust rating, information like that. And all that's it's coded information, obviously, and ECU is receiving it. Okay, so it's just I had to mention it just so you had an awareness. There is an ID plug that sends information to the ECU as well as other things. Okay, all right, that pretty much does it. Just to give you a helicopter's view, the FADEC, which stands for Full Authority Digital Engine Control, is a system, essentially is using this component called the ECU, which is your electronic control unit. Within that electronic control unit, you have a pressure subsystem enabling basically an interface with the pressure sensors. In addition to that, you also have temperature sensors that are part of the inputs that go into the ECU and then for output to the various systems that are needing that information. FADEC is in charge of complete control of the engine operations. Most importantly, on what primary parameters are, is your engine N1 and N2 speeds, making sure they're within limitations, as well as your EGT and your fuel control. On secondary parameters, that would be something like your oil temperature. Okay, thrust reverser operation is controlled by FADEC. You also have the active turbine clearance control system, also controlled by FADEC. Okay, so just know that there are also dual channel systems. So you have dual inputs and dual outputs. Okay, I hope that gives you some familiarity with the FADEC. And if you have any questions, please feel free to email. And we look forward to having you in the other lessons.